Slug 2026-06-26, how ChatGPT actually works. Target publish 2026-06-28, Saturday at 15 unquag US Eastern. You type a question. A few seconds later, a paragraph appears that sounds like a thoughtful human being wrote it. So what's actually happening in those few seconds? Most explanations land somewhere between it reads the internet and it's magic. Neither is satisfying and neither is accurate. What's really going on is both simpler and stranger than most people expect. And once you see it, you can't unsee it. Let's go through exactly how ChatGPT works, not the hand-wavy version, the real one. Start with the most important thing to understand, and probably the least obvious. ChatGPT does not think in words, it thinks in tokens. A token is a chunk of text, sometimes a whole word, sometimes just part of one. The word unbelievable might be 3 tokens. The word the is 1. Punctuation gets its own token. Spaces matter too. Why does this matter? Because everything that goes in and comes out of ChatGPT, your question, its answer, the conversation history, gets converted into a long sequence of numbered tokens first. The model never sees letters, it sees numbers. Now, what does the model actually do with those numbers? Here's the core of it. It predicts what comes next, I said. That's it. That's the fundamental operation. Given a sequence of tokens, the model assigns a probability to every possible next token. Then it picks one, appends it to the sequence, and repeats. Word by word, token by token, until it decides to stop. This sounds almost too simple to produce anything useful. But the key is in how the model learned to make those predictions. Training on the shape of human thought, the original GPT models were trained on an enormous slice of text from the internet. Books, articles, code, forum posts, Wikipedia, and more. The training task was brutally simple. Given the first part of a sentence, predict the rest. Then check the prediction against the real text. Adjust the model's internal settings slightly when it's wrong. Repeat this billions of times across trillions of words. What emerges from that process is something genuinely surprising. The model never memorized facts directly. Instead, it learned the deep statistical patterns of how ideas connect, how arguments build, how explanations unfold, what tends to follow what. It internalized the shape of human reasoning by reading an almost incomprehensible amount of it. Inside the transformer, the architecture that makes this possible is called a transformer. Without getting lost in the math, the key idea is something called attention. When the model is predicting the next token, it doesn't treat all the previous tokens equally. It learns to pay selective attention, to weight some tokens much more heavily than others, depending on context. When you ask, what is the capital of France? The model attends very strongly to capital and France when deciding what comes next. And it does this across multiple layers, simultaneously, each layer picking up different kinds of relationships. Some layers track grammar, some track topic, some track who is talking about what. By the time a prediction reaches the output, it's informed by a rich, layered reading of everything that came before. Say, GPT-4, the model behind ChatGPT, does this across dozens of layers and billions of learned parameters. Each parameter is a tiny dial that got tuned bit by bit through all that training. Together they form something that looks, from the outside, a lot like understanding. What OpenAI did after training the base model was something called reinforcement learning from human feedback, or RLHF. Here's how it worked. They hired human raters to look at responses the model generated and rank them. This one is better, this one is worse. Those rankings were used to train a second model, called a reward model, that learned to predict which outputs humans would prefer. Then the language model was fine-tuned to score well on that reward model. This process shifted the model's behavior dramatically. A raw language model will predict whatever text is statistically likely to follow your input, which means if you ask it something ambiguous, it might output more of the question rather than an answer. RLHF trained ChatGPT to be specifically helpful, to answer questions directly, to decline things it shouldn't do, and to produce responses that feel satisfying to a human reader. That feels satisfying part is worth sitting with for a moment. It does not mean is correct. Why ChatGPT makes things up? Here's the thing that trips most people up. ChatGPT was not trained to retrieve facts. It was trained to produce tokens that a human would find reasonable and coherent given the context. Most of the time, those happen to be accurate, because accuracy is a pattern the model picked up from reading accurate text. But when the model doesn't have strong signal, it doesn't say, "I don't know." It generates something that fits the shape of a confident answer. This is what researchers call a hallucination. The model isn't lying. It doesn't have intentions. It's doing exactly what it learned to do: produce the most plausible sounding continuation of your prompt. Sometimes that continuation happens to be wrong. This is not a bug that will necessarily go away with more training data. It's a consequence of what the model fundamentally is: a very sophisticated predictor, not a fact database. So here's what ChatGPT actually is. It's a system that read an enormous slice of human writing, learned the deep patterns of how we reason, argue, explain, and connect ideas, and then was fine-tuned to direct that ability toward being helpful to you. When it's working well, it's remarkable. It can draft code, explain complex topics, argue multiple sides of a debate, and produce writing that sounds like a competent human being, because in some statistical sense, it is reflecting competent human writing back at you. When it fails, it usually fails in a specific way. It sounds confident when it shouldn't. It produces the shape of a good answer without the substance. And because it's fluent, the errors are easy to miss. The honest way to think about ChatGPT is as an extremely sophisticated mirror. It reflects the patterns of human knowledge at scale. What it reflects is only as good as what it learned from, and it can't tell you which parts it's getting right. That's not a reason not to use it. It's a reason to use it with your eyes open. If this kind of under-the-hood explanation is useful to you, there's more here. We cover how AI alignment works, why AI chips are so expensive, and what it actually means when a model has a 100,000 token context window. Subscribe if you want the real version, not the hand-wavy one. Token. The basic unit ChatGPT reads and writes a chunk of text, usually a word or part of a word, transformer. The neural network architecture that powers ChatGPT uses attention to weigh which parts of context matter most. Attention, a mechanism that lets the model focus on the most relevant tokens when predicting what comes next. RLHF, reinforcement learning from human feedback. Training technique that used human ratings to make ChatGPT helpful and well-behaved. Hallucination, when a model generates a confident-sounding response that isn't accurate, not a lie, just a plausible-sounding prediction. Parameters, the billions of learned numerical settings inside the model that encode what it knows about language.